Welcome to clickmyproject.com. Let's discuss about the product. Our product is a joint encryption and error correction method used in satellite communications. Due to the ubiquitous open air links and complex electromagnetic environment in satellite communications, how to ensure the security and reliability of the information through the satellite communication is an urgent problem. This paper combines the AES, that is Advanced Encryption Standard, with LDPC, Low Density Parity Check Code, to design a secure and reliable error correction method, SEEC, that is called Satellite Encryption and Error Correction. This method selects the LDPC codes which is suitable for satellite communications and uses the AES round key to control the encoding process. At the same time, proposes a new algorithm of round key generation. Based on a fairly good property in the error correction in satellite communications, the method improves the security of the system, achieves a shorter key size, and then makes key management easier. Eventually, the method shows a great error correction capability and encryption effort by the MATLAB simulation. Satellite communications have the advantages of large coverages, wide bandwidth, huge capacity, flexibility in different business, stable and reliable performance, and no geographical restrictions. What's more, the cost has nothing to do with the distance. It is now widely used in military communications, emergency communications, and the field of radio and televisions. It will become a focus in mobile communications research. In satellite communications, due to fading, noise, and interference, the signal will come through the serious problem. Existing satellite communications technology divides encryption and error correction into two steps. That's to say, to encrypt the information first and then to encode the encrypted data by error corrected coding. The step-by-step method not only increases the complexity of the system but also leads to a longer delay. This will result in restrained system efficiency and limit the further minimization of the base chip. Here, this is our system design of the development. Here, we have combined two tools which is called MATLAB and Xilinx, because we have used a file, that is a text file, as the input. We are going to encrypt a text file. So we are converting text file into binary values in MATLAB, and we are passing the binary values to the Xilinx. In Xilinx, its binary values are encrypted, and encrypted values are again converted into text. So for that processes, we have combined MATLAB with Xilinx. So this is our process. So we have designed the AES architecture, and we are applying that encryption message which we have to encrypt. After that, we are applying LDPC, low density parity check, and that is also based on Euclidean geometry, that is as our enhancement. So in this process, we can conclude that we have enhanced with Euclidean geometry based LDPC. Let's see the running procedure of our AES process. Here we have processed the design system with combination of MATLAB and Xilinx. Here initially the code in MATLAB processes the key, and then the bits which I have to encrypt is converted from text to bit, and the bits are passed to Xilinx. So here main function.m, this is the main file which we have to run. So after running the main file, we will get a small menu bar. So we have executed the main function.m file. This is the MATLAB file. So here what we have done is, we have read that input text file which we have to encrypt. That encrypt text is converted from text to bits, and the converted bits are going to pass to Xilinx. So I am selecting the option which what I am going to do. I have selected encryption. So for encryption, what I am doing is just I am passing a key, which is the key I am using for encryption. So at this time, that Xilinx bar is opening. So the process from text to bits are converted, and the converted bits are passed to Xilinx ISE simulator. So here is our process. Here what I am going to do is I am just running this, simulating this code. So it will take some time to complete the simulation. Here simulate behavior model, we have to select the main module here and we have to click simulate behavior model, and then iSim will open. Here what we have to do is we have to apply the parameters force constant. So I am setting the values and making enable as 1. So I am running the procedure and finally the bits are encrypted. So now I am going to see the encrypted result in MATLAB. Here while I am clicking entering any button, so the cipher text will open here. So for the decryption also we have to do the same procedure. Here for the performance of encryption we can click this menu bar. So after that clicking the menu button we will get the performance results. This is the cipher text. So for the decryption also we have to use this same key to decrypt this text. So this is the time delay or comparison between existing and proposed. And this is the statistics on number of correct key bytes. So I am doing the same thing for decryption. I'm choosing decryption, entering the key. See, as the same process, it will convert that encrypted text. It will read the encrypted text and the passing to Xilinx. Here Xilinx open. So here we have to do the same procedure which we have done for encryption. So here I am selecting the main module and doing simulate behavior model. So as usual running time, it will take some time to simulate to complete the elaboration. So after this elaboration the process will open here. I'm running. Thank you.